Bio-IMEI is one of my favorite projects, and this will be a massive project. I'm hoping that several of you will be able to come on board with this. We have a SIM card in a phone. We're going to take it out of a phone. We're going to break a phone. We're going to put it into either a pendant or a ring. I don't care if it looks like Green Lantern's ring, we're just going to put it into something else. But you're going to have this ability to biometrically touch anyone's phone or PDA, and it should log in with your profile. That means we're changing the nature of mobile devices. You don't put a SIM card in a phone, you carry your SIM card because it's you, right? So if you touch someone's phone, if you touch someone's tablet, it should load up with your contacts, your web preferences. Your profile is stored on the cloud. Microsoft will provide you the cloud. Orange will provide you the network bandwidth. Nokia will provide you with handsets that you can break. And we have other companies, hopefully ARM will come on board and give us ARM platforms that we can use as a prototype. A 3G receiver that takes the SIM data and transfers it to a phone wirelessly. Right? This is really the essence of proof of concept. No one's done this before. So this will be a really nice project. The Metropolitan Police have another project with Orange, and this is called ProtectWear, and this is wearable devices, embedded sensors on clothing. So again, we're looking at clothing techniques and technologies. If there's a riot happening and audio goes over a certain limit, certain things should trigger. What sensors can you imagine for the police of the future to be wearing? Okay? This is an envisioning exercise. We want to know what ideas you might have. Yeah? What things would you need to have on a police jacket that you could relay information as quickly as possible? Now, we're getting 4G access from the clothing, and also Nokia have given us a rapid-fire CCD component, so that within half a second, we'll open the CCD channel, transmit the video data of a snapshot, and within a second complete the cycle to upload. Right? What it means is that your wallet's being stolen. As soon as you open it, it's taking a photo. It's transmitted. So there's some really nice case studies that we can use with this.
Dean, you might actually be running a fashion show as well.
So we can make use of that.
Technology.
So that would be a great place to showcase this. Yeah? We have 4 groups at the Met Police who want this. You'll actually have the ability to trial it with police officers. Okay, another one of my favorites. This one's called Captain. So we're in this big data world. Data about us is being collected everywhere, right? There are sensors being triggered. We go through a door in a supermarket and a sensor's been triggered, a CCTV is fired, and information has gone through. Imagine you've got a hospital ward and you have 100 sensors in that ward. You've got heart rate monitors, you've got blood pressure gauges, you've got a whole bunch of different sensors firing. They have their different thresholds, different values. But they have what we call a taxonomy map. A taxonomy map means a classification. These sensors are digital, these ones are analog. These sensors have these threshold values. These sensors, they can relay information. What sensors can you interoperate, interuse? Which sensors are uniquely on their own? Yeah? Have you heard of the word taxonomy before? Classification? Like, you've got periodic tables, classification. You've got birds and you've got animals, and it's classification, groupings of sensors. That's what we're talking about. Now, we want to create an ARM board. We want you to design this board from scratch, and we want you to be able to create a protocol with our CS students that can retrieve up to 100 sensors simultaneously. So if I say Fitness First are on board with this, the gym, they want to put this little box, this little round box, in the corner of every gym hall, and all the sensors on each of the exercise equipment have their own classification. It retrieves the sensor information. These dumbbells are in use, you know, this rowing machine is in use, etc., and how fast they're being operated. All the data regarding those sensors is being translated to that little box. Okay, that's why it's called Captain. It's the captain of a group of sensors. What's going to happen next is that it has to have some smart software on it to profile each of these sensor readings and say what their limits are, so that we can send it up to the cloud for big data aggregation. Now, every single Fitness First in the country will have these in every single room, and they'll collect each of them 100 sensors, will pass all of that information for calculation, which part of the country is using this type of gym equipment the most effectively. Yeah? If it's in a hospital, are these hospital equipment being used effectively? This has a whole range of sponsors behind it. There is a definite need for this technology This is like a command and control platform for the Internet of Things. Before the data just goes from a sensor straight to the web, we have to profile the data, filter the data for noise, remove results that are irrelevant, and pass us information that is of valid reason. Okay. I can tell you the design of this project, this idea was a joint project with UCL and Bill Buxton, who is principal researcher for Microsoft. He has 40,000 people working for him. So this is a very important platform that they want to see built. Okay, a fun one. How many of you have got old phones, old PDAs in your drawers? Yeah, they're just lying there. Why don't you just break it open and make something out of it? This is a Cyan Organizer. 20 years ago, in 1993 it launched. It was ARM's first major product platform. Right? The Cyans were the original ARM specification. This was at a time when they were developing their own hardware. And what's interesting about this is that it has a very nice punchy keyboard. Right? It's not like two little buttons, dinky buttons. It's actually proper springy keyboard. It had a stylus. It had a resistive screen. Okay, fine. It's not capacitive. But it had apps as stickers. Yeah? So when you touch each one of these, it goes directly to the application. More importantly, it had 2 Duracells that lasted 30 days. I could do my Word, Excel, I could do my internet basic browsing. It was like Netscape like. I had email on it. In fact, when I was 16, I wrote an FTP client for this. It transmitted data over infrared, and that was very, very slow. You can even transfer an MP3 file over infrared. So this is a back-in-the-day technology. Now, what we want to do is, we'll get you several of these, and we're going to break them. We're going to take out certain parts of them. Microsoft, the Visual Studio team, they are extremely interested in this. What if, in this era of doing everything on the web, we could put HTML5, modern web browsing capabilities, Facebook, all that stuff, and be able to make use of all the apps that we used to have. Word, Excel, internet, email, just through a web browser, right? What do we need to do this? We need a micro operating system that can run WebKit. We need to be able to support a black and white screen, so we're going to need some drivers for that. We are going to need an SSD, so we want it to run as fast as possible on flash memory. And it has to be powered by 2 Duracells, so we need to look at all the power outputs, all the voltages, and wire this in to make it run as though it's a modern technology, but based on older designs, older hardware, right? This is putting recycling technology completely on its head. If you can do it with this, then you can form a formula, a process, a methodology to look through all these old phones, old devices, and recreate it for modern technologies. What would it take to put a Nokia that was 20 years ago with 4G access? What do you need, right? This is a great experiment to look at. And we will have several of these devices. Okay, cytoplasm. Sorry, I'm nearly finished for those of you that are tired. I'm sorry. It's a lot to take in at once. Cytoplasm is about the Internet of Things, so this will be on the competition, about pairing things over a very wide distribution network. So, I have a heart rate monitor. It's monitoring me and it's recording, it's logging me. But I want this information in New York. Okay? I want to be able to subscribe, and I want groups of subscribers. So this is looking at how do we create protocols for these sensors that can disseminate this information over the Internet of Things. Okay? You might need the Captain device to push it out. You might need other platforms like on the Facebook project, how you light things. You might need RFIDs. You might need a whole bunch of other things to make this happen. But this pairing over a wide area, this is like a virtual cytoplasm. It's how things get contained across the Internet of Things. So, my favorite mouse, my favorite keyboard, my stuff here is interoperating with a whole bunch of sensors in someone's house in another country, right? How these things get grouped together. Okay, recently the Department of Computer Science have constructed our own Arduino from scratch. So we looked at the Arduino platform, the LilyPad platform in particular, and we found that we can create our own circuit. We designed the circuit, we've got it manufacturing now. Right? What I want to see from the Fleming Society for this is to augment this with your own sensors, with your own other devices, and add into the pinouts We have several pinouts here on the expansion bus. If I want to make this Wi-Fi capable or Bluetooth capable, I want to make some new type of radio frequency or RFID reader to augment these Arduinos with additional facilities. What else can we do with it? So let me tell you about what we're currently doing in this. We have 1,500 of these about to be deployed in schools across the country. I have a team of 4 students that will be creating a learning toolkit. They'll be able to drag and drop code and say, hi, it's got an accelerometer, so we want to balance whether a plank of wood is level. Or we want to have, with the temperature, sorry, it's on the other side of it, we have the temperature, maybe you want to capture temperature readings of soil. Or even better, with your pinout, plug in a pH meter of soil. These are high school kids. They'll be using the circuit, capturing data for the first time, and they'll be building their first ever apps, right? We want to augment this with a whole bunch of different sensors. So there might be some really nice opportunities here. And this comes from Anthony Finkelstein, who's the Dean of Engineering. He wants to see this rolled out with a wide spectrum of uses. It might not just be for teaching. You might have it in healthcare. You might have it for a lot of different uses. But as it stands, we've got a few sensors that we can manipulate. And more importantly, Microsoft have given us 8 engineers at Microsoft Redmond to build .NET compatibility for this. So you can control it from Windows, you can control it from other platforms. And the final one is another one from Bill Buxton. Our students together, all of them combined, Management Science, EE and CS, are going to design a new type of hard drive. Currently, Seagate, the manufacturer, have a wireless hard drive, but it only has a one-way Wi-Fi signal that lets you log in from your computer straight to the drive. We want this hard drive to go in your backpack. Microsoft Research have published a device driver that lets you split up that Wi-Fi signal. And if you have an interest in radio frequencies, we want to be able to analyze that signal and to be able to create a connection jointly to a phone, to a laptop, and to the cloud simultaneously. Yeah? This is several Wi-Fi signals happening on one hard drive, and an operating system for that hard drive will be built. What will happen is that as you're doing your navigation, as you're retrieving files from your portable drive, you patch data. You don't download all of your photographs at once from the cloud. As you start accessing the photographs, it knows what you're accessing, and then it will buffer what comes next from the cloud. Okay? This means that your life and your world, you get this intermediary level that you can access. And it means that you will have this ability to transfer data and patch information with reliability in this model that is in your backpack. Okay? So I think I've said quite a lot about what kind of projects we're dealing with. But this is where I wanted to tell you that you have the Fleming Society, and what we want for all of you is to experience working with computer science, working with management science, working with art students to actually construct a concrete product. You have the companies backing you on your CVs. Yeah? We recommend that if you have your Wednesday afternoons for the Fleming Society, then we allocate our students, all those different categories of students, to meet up on Wednesdays, and you'll get a notification that you are part of this project. You would probably have a voting system of some kind, I guess, to choose which projects you might want to be a part of. We'll get you all of the hardware. You'll start getting to meet the clients with the students all together. And for 1 year, we see what you can publish. We see what you can produce. We see what you can bring to market on Kickstarter with your own names on it. Right? So you have Fleming Society. What we have in CS is called the SSIGs, the Student Special Interest Groups. And I want to nominate the Fleming Society Facebook page to be created as a Fleming Society joint SSIG, where we bring in all these students together so you can start communicating with them. I think I've said quite a lot.
Any questions, maybe, at this
Yes.
point?
How are teams allocated? How do you get on?
How?
So I think
How are teams?
How do you get onto the projects? How do
Yeah,
you-
we'll talk about it now, I think. Thank you, Dean. I hope you all liked it as I liked it in the beginning.
Where can we find these projects to look at them again?
We'll talk about it
we'll email it
now,
to
like
you.
everything,
Yeah. So everything,
according to the
all the
Fleming
material-
Society.
all
we'll
the
talk about it.
materials we publish on the Fleming Society, And we'll say that from next Wednesday will be the first session that you'll get to meet the CS and Management Science students. Okay? The students have already started this. They've had 2 weeks to start researching and reviewing it. Some of them have already started to meet the clients. So you coming on board now, you'll get that added information and instructions that can help get you started. You might have your own ideas. You might want to bring in hardware and particular models and methods that you want to start with that you can suggest to our students. Remember, our students, they don't know what you know, and it would be nice to have that agreement of ideas from the very beginning. Yeah? Remember, no one is anyone's master in this project. Everyone is working equally, and if you say that you're taking part in this project, that means you sign on for a year. This is not something that you sign on for a week or two and then you're like, oh, I've got other things to deal with. This is you having Microsoft sign a letter of recommendation with your name on it. Right?
Right. Thank you very much. So maybe I'll take over now. You've seen the projects. We've got a sign-up form on Google Forms. So if you're interested, if you like any of these, we'll post a link on Facebook. On these two computers, they're open. So I guess there are too many of you now, so it's not going to work. So just check our Facebook page. There's going to be a form. Write your name, year of your study, email, and the project you're interested in. In, I hope, about a week time, we'll see how many responses we got. Which projects need like more, maybe somewhere there are too many people, so we have to assign you more. Maybe there's going to be like a backup project if there are two that you like. And I think that's it for this. In Fleming on Wednesdays we're going to have late sessions up to like 8 o'clock or 9 o'clock. We'll see how long it's going to take. Maybe on Mondays as well. I know lots of you got sports and other activities on Wednesday, so maybe we'll consider Mondays as well. And all the other days during the week, if you find a piece of table that's spare, and there's plenty of it, you can come as well. So are there any questions at this point?
Can we ask about if you want to know more about the projects before we see
all the projects should have some more details. I hope in a week there's for each project.
You said already 2 weeks ago doing this project, right?
Yeah, so you can meet
we
the
ask
groups.
people
Yeah, you can go to the group. So
go to them.
I have a session tomorrow. I'll email you the times that they're in their sessions, and there's a session on Friday morning as well. Because we have 90 students working on this.
Yeah. It's a very early project. I just got to know yesterday. I wanted to make it happen as quick as possible. So there are still things that needs to be sorted out, but hopefully by the end of this week we'll know more. Any questions? Okay. Thank you again.
Thank you.
We as Fleming were supposed to run the autonomous robot competition introduction. I don't know if you still have some strength and power, or was it too
10 minutes, 15
much for
tops.
you?
Promise. Thank you,
You
promise.
can add the robocop onto that.
Okay.
Yeah. that would be something.
So maybe voting, because if not, we can move it to a different date. Because do you want to listen about the autonomous robot today, or do you
10
want to
minutes,
10
promise.
minutes?
Yeah.
Okay.
Yeah.
So.